Hey, what's going on YouTube? My name is Chris and welcome back to ImmodderNation. For those of you that are just joining us, this is the second part in a two-part series about the Valve Steam Link. If you haven't seen the first video yet, make sure you click on the video in the upper right-hand corner to check that one out. Wait, was I wearing this shirt last week? Hold on. No, not this one. Much better. Part 2 starts right now.
I scoured the internet looking for a large Steam logo. I printed it, cut it out, and made it into a stencil. My idea is to attach the stencil and spray over it with frosted glass spray to give it an etched glass look. I don't own or have access to a CNC router, so this is the route that I will take. That was a pun. I don't recommend cutting the acrylic with a rotary tool because the heat generated can melt the plastic, but if you do, low speed and a fiberglass cutoff wheel. And wear eye protection. I'm not responsible for bits of plastic in your eye. Now I'm cutting out the remaining pieces of the stencil with my Trump scissors. Did you know these were made in China? This will allow paint through the middle and enhance the design of the Steam logo. Plus I need an excuse to make a Trump joke. I laid it out on the plastic to see what it looked like. I'm using white glue, but any weak bonding adhesive should work. I'm peeling this off later, so super glue or hot glue is a no-go. Tap it with a lens cap for good measure. For the frosted glass, I recommend 1 or 2 coats at a time. You can see the frost effect happening before your very eyes. It's magic. I'm like a magician. Now that our acrylic is finished, it's time to peel. I'm using a plastic razor blade to remove the Steam stencil. Auto body shops use these to apply and remove graphics from cars. Today, I'm using it to remove my warranty. And here's the finished result, but I'm not satisfied, so I'm printing out a new design and doing it again.
A few moments later.
The most astute of observers will notice the logo is backwards this time. This is to keep the painted side on the inside where it won't get damaged as easily. I flipped the logo so that it appears in the correct orientation when I glue it down. I carefully used my X-Acto knife to remove the paper and cleaned it up with the razor blade. I'm taking my time with this part because the X-Acto knife could easily scrape the plastic. Then I hit it with some rubbing alcohol and a Q-tip to remove the haze. Then some Arctic Clean Solution 1. Finally finished off with some Meguiar's plastics to give it that shine. Not really. This stuff is used to remove haze from plastic headlights, so I thought, what the hell, why not? Maybe a few more times. Next, I mounted the switch, and I wanted the switch in an area that had enough room and I wouldn't have to run wire throughout the Steam Link. The right side worked out well. In order to mount the switch, I'm using a cordless drill with a 1mm drill bit, followed by a 4mm to bore it out. Oh yeah. Excuse me. When you see that switch poking through, that means it's time for some hot glue. Here's our finalized Steam Link window. It cleaned up very well. It's still a little bit hazy, but at some point you have to say good enough or else you'll never get the project done. Make sure you check the orientation of the window before gluing it down. Glue must be on the outside. Glue the corner so you can't see the adhesive. Press it down and hold in place once it's lined up. Next, I constructed an array of LEDs wired in parallel, not series wiring, and here's why. When you wire LEDs in series, the voltage draw becomes additive. 3 LEDs that require 3 volts each draw a total of 9 volts. Keep in mind that our input voltage is only 5.1 volts, so this simply won't work. However, when we wire the LEDs in parallel, the voltage is only 3 volts, and the effect on current draw becomes additive, requiring a total of 60 milliamps. You have to wire individual resistors for each LED, and your question is why? Well, please consider the following scenario. Here are some animated images that explain why using a single resistor won't work. In the top image, we see our ideal scenario. One resistor for 4 LEDs wired in parallel produces 4 lit LEDs. So what's the problem? This never happens. The reality is actually detailed in image number 2, where you have few LEDs lit and the lighting is uneven. Here's the schematic that I spent way too much time working on in MS Paint. We can see our 5.1 input voltage is wired in parallel to 3 corresponding resistors and their LEDs, followed by a switch. Remember, the resistors are 110 ohms? Seems simple enough, right? Theoretical science is one thing and actual testing is another, so I wanted to test out this concept using a 9-volt battery. Yes, I realize this battery is not 9 volts, it's actually close to about 5.1 volts. If the voltage were any higher, these LEDs would have burned out by now. Next comes the arduous task of gluing in each of these LEDs. Yeah, I realize that looks gross. Whatever. Once the LEDs were glued in, I connected the leads together and added some heat shrink. Now comes the process of melting the heat shrink using the soldering iron. You actually don't want to do this. It'd be better to use a heat gun, but I got lazy and I had a soldering iron, so don't try this at home. The wiring may look ugly, but remember, people can't see true beauty on the inside, so make sure you're beautiful on the outside. Right, so after we've connected our leads to the switch, it's time to connect the leads to our power source. And remember, soldering irons are hot and they will burn your steam link. Can't fix it now. This time I carefully soldered the other wire to the terminal. And now that we're done, we reassemble it. The heatsink fell off. Well, better stick that back on. Once the wires are carefully tucked in, we can slowly snap the steam link back together. And that's all she wrote. We have our steam link finally back together. All that's left to do is to plug in the steam link and turn it on, make sure it works. And there it is. Oh my God, it is so beautiful. I went ahead and mounted it on my wall just below the TV. You know, I'm not completely satisfied with the way it looks, and that's why I'm ranking it as a 10-foot mod, because it looks great from 10 feet away.
So what do I think about the final result? I think it turned out great, but there are many things that I would have done differently. The first thing that I would have done differently is to hand file the ring that I cut inside of the steam link instead of using my rotary tool. I think that created the biggest problem by creating kind of an egg shape instead of a circle. The second thing I would have done differently is to add more layers of paint, because I feel like having more spray paint on the acrylic would have made the final product look a lot clearer from far away. The third thing I would have done differently is, instead of using glue, I would have used something like these adhesive labels. I can print onto this with my printer and then simply stick them on. They already have an adhesive backing, so it'd be really easy to do. Something like this will easily just peel off, not a problem. Another thing that I would have done differently is to better wire up the LEDs. I think I had wired up the LEDs before I had a plan as to how I was going to install them in there. I feel like the wiring was alright, but it is something I could improve on in the future. So while there's lots of room for improvement in this project, I do have this to say. There's a quote by a great American inventor by the name of Thomas Edison, and he says, quote, "Our greatest weakness lies in giving up. The most certain way to succeed is always to try just one more time." And throughout this video, I've shown you a lot of the successes and a lot of the troubleshooting that I've done during this project. But what you didn't see is all of the times that I screwed up. Times where I had to backtrack, where things didn't work out the way that I wanted. And I really spent more than just 10 or 15 minutes that you see in these videos. I spent weeks working on this project, trying to figure out what is the best way that I can put this thing together. And yeah, I ran into a lot of trouble. I ran into roadblocks. I ran into things that didn't work out the way that I wanted to, and I had to troubleshoot on the fly exactly how I was going to get this figured out. I hope you really enjoyed this video, as I put a lot of time and effort into it. If you did, make sure you click on that thumbs up. It really helps me out. Leave a comment down in the comment section letting me know, has this video inspired you to create your own mods, to go beyond simple water cooling or case modding, to do something different. Oh. Join the nation and get subscribed by clicking on that subscribe button below. That way you don't miss a single video when it comes out. As always, you can contact me on one of these social medias that are listed somewhere here. Thanks for watching, and I'll see you again soon.